Welcome back, guys. So, we're gonna start today with determinants. I was gonna do inverse matrices first, but then I realized that in order to do the inverse of a 2 by 2, you can use the determinant, and so we're gonna go through this first. The determinant is just a number, and you calculate this number using a matrix. It's pretty straightforward for 2 by 2s. It's always the same. For 3 by 3s, you can do it different ways. I'll show you the way that I prefer you do it, only because I think it's probably easier for my students to remember. And so let's go and look through this. Determinants can be used to solve systems of equations via Kramer's rule. So remember, solving systems of equations involves we can use substitution, elimination. We can use RREF, which is Gauss-Jordan elimination. We can use, there was another one we talked about originally. Oh, we can, I don't remember what the other one was off the top of my head right now. But anyways, determinants are another way that you can do this. To calculate a determinant, determinants can only be taken of square matrices, so you'll never have a rectangular 3 by 2 or 2 by 3 or 2 by 4 or whatever that you're able to take a determinant of. But if you have a square matrix A1, B1, A2, B2, and it's denoted by this obviously means that you're taking a determinant. And it's defined as, the determinant's defined as this top left corner times this bottom right corner minus this top right corner times this bottom left corner. So, to calculate it, it's very simple, and I'll go through that right now. So the first thing we're going to do is we have the matrix 5, 6, 7, 3. So let me write that down real fast for you. So if we go and we have matrix matrix 5, 6, 5, 6, 7, 3. Yeah. Then all we do, if we want to find the determinant of that matrix, it's like absolute values. It's not absolute values, but it's like it. It's the same symbol. 5 times 3 minus 6 times 7. 15 minus 42, which is 32, 27, negative 27, I think. I hope. So as you can see, it's just a number that you're going to calculate. And we'll do another one real quick. We'll do 2, 4, negative 3, negative 5. So we've got B. Okay. So then the determinant of B is equal to 2, 4, negative 3, negative 5, which is going to be 2 times negative 5 minus 4 times negative 3. This is negative 10 minus negative 12. Negative 10 plus 12, which is 2. And so we should get a determinant of that, and that will be that. Now, another thing I should tell you, since we're talking about determinants, you can take determinants of 3 by 3 matrices, or you can apply Kramer's rule. So let's just look at Kramer's rule real quick. What you can do with this is if you're looking at questions like these bottom 13, 14, 31, and 32, you can use this rule to solve these systems and figure out what x and y should be to make these true. However, let's go and look at, did we do number 1? No, we didn't look at number 1. Okay, so if I take these ones, I'm just going to move these over to my, oops. Move these over to my whiteboard. So if we have these equations, we can do some more practice. We have a 3 by 3 now, and I'll show you how to do those. I'll show you 2 ways of how to do those. There's They're a little bit more tricky, but I know a pretty good method that works fairly well, and I think you'll like it. So if we do number 1, we have 5, 7, 2, and 3. And this is going to be 5 times 3 minus 7 times 2, which is equal to 15 minus 14, which is 1. The determinant's important because if it's equal to 0, it can tell us that the matrix has no inverse matrix, which is something we're going to talk about soon in another video for this week that we're doing. But we can keep calculating some determinants. So if we do this one, this is 4 times 6 minus 8 times 5. Not 55. 24 minus 40, which I think is negative 16. Okay, so let's look at a 3 by 3 now, because those are a little bit more challenging. We've got 3, 0, 0, 2, 1, negative 5, 2, 5, and negative 1. Now, to do this, there's a couple things you have to note. The first thing is you're going to have positions. So these are positive, negative, positive, negative, positive, negative, and positive, negative, positive. So it just alternates. What this means is you're going to take, so here's how this works. First thing we're going to do is we're going to select a position to start in. We're going to use this first row only because it's going to be the easiest, because I'm going to have zeros and I'm going to multiply by 0 in some parts. So the first thing I'm going to do this in red, is I have to do this 3, and I'm going to write that 3 here. Okay? That 3 is not going to take the determinant with anything in this row or this, this row or this column. So what does that leave? That leaves everything in here. So we're going to take the determinant of that. 1, negative 1, 5, and negative 5. Okay. So that's the first one. Then we're going to do, so we started with 3, we're going to go right. Now we're going to go to 0, but 0 is negative. So we have minus, parentheses 0, times the determinant of what's not in the same row and column as 0. So this is the row with 0, or I'm sorry, column with 0, this is the row. These two and these two go with this determinant. So we're going to do 2, negative 5, 2, and negative 1. Okay. Then we're going to go right one more time, this one. So we have plus 0. So these signs, this is positive, this is negative, this is positive, that's where this came from. Okay, if you can do this in any order and you'll still get the same number when you multiply all this. It's kind of the bizarre thing about these. So the last one, we're going to take the determinant. Well, we can't use anything in this row, or I'm sorry, this column or this row. There's us with 2, 1, 2, and 5. So let's do the math on this real quick. We have 3 times the determinant of this thing, which is going to be 1 times negative 1, minus 5 times negative 5, which is that, minus 0 times 2 times negative 1, minus negative 5 times 2, and finally plus 0 times 2 times 5, minus 1 times 2. Okay. So this is going to be 3 times negative 1 plus 25 minus 0 plus 0, right? Because this is 0 times this. Who cares what this is? This is 0 times that. That's 0. Which finally gives us 3 times 24, which is 72. Okay, so that should be our answer for that. So that's one way of doing it. I'm going to do another way. That might be the quickest way in this case because these have zeros in them, but they don't always have zeros, and when they don't, it makes it not fun to calculate. So let's do 24, and I'm going to show you the other way you can do this. You have 4, 0, 0, 3, 2, negative 1, negative 3, and 4, and 5. Okay, so a trick that one of my professors showed me a while ago was that these are symmetric, and because of the symmetry of them, if you just simply copy the first two columns, so that would be 4, 3, 2, and 0, -1, 3. So I've copied these first two columns. And then what we're going to do is we're going to go sideways. So from this top corner, we're going to multiply these, and these, and then we're going to stop. We start in this corner, we end in this corner. So this is going to be 4 times -1 times 5 plus, these are all pluses, 0 times 4 times 2 plus 0 times 3 times 3. Okay, that's the first part. And I'm going to need some more space. Oops, I'm going to need this one. So we're going to go like this. Come on, we're going to move all this over. Okay, that's over here. Then we are going to do minus, and I'm going to put a big bracket around this just so that I can keep space. And I'm going to need some more space, so I'm getting rid of this. Okay, so we got a big bracket. We're going to do the ones starting in this corner, going backwards. These ones, and these ones, 3 of them. So we've got 0 times 3 times 5 plus 4 times -3, and then plus 0 times -1 times 2. That's that one. Okay, so that's taken care of. And so we multiply this out. This is -20 plus 0 minus 0 plus, actually not plus, minus 16 times 3 minus 48 plus 0, which is going to be -20 minus -48, which is -20 plus 48, which is finally 28, and that will be the determinant of this matrix. So it's important that you be able to find those. I'm going to show you how to do Kramer's rule next, because we're going to go out of order on this, and then we'll show you inverses, and hopefully you can do inverses a little bit quicker after we're done learning how to do a determinant. Thank you guys for watching.